Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present about differentiation in calculus. What is differentiation? Differentiation is all about finding rate of change one of quantity compared to another. We need differentiation when the rate of change is not constant. Secondly, development of differential calculus. Up until the time of Newton and Leibniz, there was no reliable way to describe or predict this constantly changing velocity. There was a real need to understand how constantly varying quantities could be analyzed and predicted. That's why they developed differential calculus, which we will learn about in the next few chapters. And last but not least, why we need to study differentiation. There are many applications of differentiation in science and engineering. You can see some of these in applications of differentiation. Differentiation is also used in analysis of finance and economics. One important application of differentiation is in the area of the optimization, which means finding the condition for a maximum or minimum to occur. This is important in business, such as cost reduction, profit increase, and also engineering, which is maximum strength and minimum cost. That's all about differentiation. Thank you.
Now, we get into the problem statement. Let's go. The Rolle's theorem states that if fx is differentiable on AB, continuous on AB, and fa equal to fb, then there is at least one point C in AB where f prime C equal to 0. If fx equal to x squared minus 3x, find the value of C in the interval 0, 3 that satisfies the Rolle's theorem. So, the question is, if fx equal to x squared minus 3x, the question asks us to find the value of C in the interval 0, 3 that satisfy the Rolle's theorem. So, where is the solution? Wait for it.
Read the question first. The Rolle's theorem states that if fx is differentiable on AB, continuous on AB, and fa is equal to fb, then there is at least one point C in AB where f prime C is equal to 0. If fx equal to x squared minus 3x, find the value of C in the interval 0, 3 that satisfy the Rolle's theorem. My suggestion first is write the equation first so we can avoid any careless. Okay, we move to the next step. We put the value in our equation. Okay, we start with a first, which is 0. So the equation will be 0 square minus 3 times 0 is equal to 0. Okay, and we move to the value of b, which is 3. Okay, so the equation will be 3 square minus 3 times 3, and the answer is 0 also. So the fa is equal to fb, like stated in the question. Alright, the next step is we differentiate the equation. So it will be 2x minus 3, and then we change the, x into c. So the equation will be f prime c equal to 2c minus 3. The last step is let f prime c equal to 0. So the equation will be 2c minus 3 is equal to 0. Minus 3, we move to the right side, and it will be 2c is equal to 3, and we move c to the right side also. So the equation will be C is equal to 3 over 2. So that's the value of C. Okay, that's the solution.
Conclusion for applications of differentiation. Our assessment for application of differentiation, Chapter 3, has been achieved. We have worked well with each other as a group for this group assignment, despite of the many challenges we have to put into work to complete the task given. We can now understand and interpret the applications of differentiation, especially for the Rolle's theorem that we have showed the steps to answer it perfectly in this video. Also, it can be said that the concept of Rolle's theorem can be used in our daily life in solving problems. Last but not least, we would like to say thank you to our lecturer Sir Zahari for giving us the guidelines to complete this video presentation. That is all from us. Thank you.